Olympus Mons. This colossal shield volcano is located on Mars and stands as the largest volcano ever discovered in the entire solar system. It was formed over billions of years as a single stationary volcanic hotspot beneath the Martian crust, continuously pumped out massive amounts of highly fluid basaltic lava. What makes it completely unique is its staggering scale, towering 14 miles high, which is nearly 3 times the height of Mount Everest, and spreading out over an area roughly the size of the entire state of Arizona or the country of Poland. Because Mars lacks active plate tectonics, the crust remained completely still above the lava source, allowing the mountain to grow to these impossible dimensions without shifting away. This planetary giant matters immensely because its sheer size proves how a lack of tectonic movement can fundamentally change the geology of a rocky planet and shape the landscapes of alien worlds. Maat Mons. Situated beneath the dense, scorching atmosphere of Venus, this massive shield volcano rises nearly 5 miles above the surrounding plains, making it the highest volcanic peak on the planet. Named after the ancient Egyptian goddess of truth and justice, it features a vast caldera at its peak and is surrounded by dark lava flows that stretch for hundreds of miles across the Venusian surface. It stands out to modern planetary scientists due to recent radar data from missions like Magellan, which strongly suggest that this volcano may still be actively erupting today with fresh, glowing lava flows. It represents a vital piece of the planetary puzzle because studying its ongoing activity helps us understand the volatile greenhouse environment of Venus, showing how active volcanism can continuously pump sulfur and gases into an atmosphere already choked by carbon dioxide. Loki Patera. This immense volcanic crater is located on Io, an innermost moon of Jupiter, and holds the title of the most powerful and active volcanic depression in the solar system. Rather than a traditional mountain peak, it is a massive 200-mile-wide lava lake powered by the intense gravitational flexing caused by Jupiter and its neighboring moons. This constant tidal tug-of-war generates massive internal friction and heat, creating an active lava ocean that regularly undergoes a resurfacing cycle where the cooling crust collapses and sinks back into the magma below. It was first observed in detail by the Voyager spacecraft in 1979 and has been monitored closely ever since. This hyperactive site matters because it provides a direct, real-time look at extreme tidal volcanism, a powerful process that can keep moons geologically alive and filled with liquid energy, even in the freezing outer reaches of space. Alba Mons. This extraordinarily unique volcanic structure is located in the northern Tharsis region of Mars and possesses the largest surface area of any volcano in the solar system. Unlike the steep, towering peak of Olympus Mons, this feature is incredibly flat, rising only a few miles high, while its expansive lava flows spread out over nearly 1,000 miles across the planet's surface. It formed during an early era of intense Martian geologic activity, when massive volumes of low-viscosity lava erupted through vast networks of fractures and fault lines rather than a single central vent. This distinct shape makes it a hybrid between a traditional shield volcano and a vast volcanic plain. It is highly significant to planetary science because its unusual structure reveals a critical transition phase in Martian history, illustrating how a cooling planet's crust can fracture under immense internal pressure and spread volcanic material over an entire hemisphere. Doom Mons. Located on Saturn's largest moon, Titan, this massive peak stands as the highest mountain in a complex structure believed to be a giant cryovolcano, or ice volcano. Instead of molten rock and scorching magma, this distant formation erupts a freezing mixture of water ice, liquid methane, and ammonia from deep beneath the moon's icy outer shell. It rises nearly 1 mile high and sits directly next to a deep depression known as Loki Patera, from which thick flows of icy slurry have spilled out across the landscape over time. This bizarre geological feature was mapped using advanced radar instruments on the Cassini spacecraft. It matters profoundly to modern astrobiology because it demonstrates that volcanism does not always require heat and molten rock, proving that icy worlds can use alternative chemical combinations to reshape their surfaces and potentially transport prebiotic ingredients from deep oceans up to the surface.